session is about subprograms. Okay, so we'll be looking at what are subprograms and the implementation issues related to subprograms and the design issues related to subprograms. We look at the fundamental definitions, and also we'll be looking at the type checking across the parameters, different parameter passing methods as well. Okay, so to start with, what a subprogram is? It is nothing but the block of code of instructions within the a program, right? Now, if we look at the definition of the subprogram, it is like action of subprogram abstraction. Okay, and it is like a explicit request that the subprogram be executed. Now, there are some fundamental characteristics of subprograms, like a subprogram has a single entry point. Like when a caller is calling the subprogram, the called subprogram will be executed. So that is the reason we call it as it is having only single entry point, and the caller is suspended during execution of the called subprogram. Okay. When the caller is calling, the control will be transferred to the called subprogram. That is the reason caller is suspended during the execution of the called subprogram. Then control always returns back to the caller. Like where it has been left, from there it will be starting execution again. Okay, and the following are some of the basic definitions of the subprogram. Like it has a profile, it has a header which indicates the number of parameters and the type of parameters. Okay, then a subprogram declaration provides the protocol but not the body of the subprogram. Like it will provide the protocol in the sense it will provide all the formal parameters and the functionality, the body of the subprogram. And the actual parameter represents a value or address used in the subprogram call statement. That means whenever we call a subprogram, the values which are included in the call statement are called actual parameters, and the parameters which are defined in the definition of the subprogram are the formal parameters, right? So these parameters, they can be of two types. They can be positional or keyword. Positional in the sense we follow in the call statement the order of the parameters so that they will be as it is the same order will be assigned to the formal parameters. That is one case, and in the other case the parameters are called as keyword parameters. They are called as keyword parameters. Like we can see the example here. Here we will be mentioning list is assigned to a is assigned, sorry, list is assigned to a and length is assigned to n. Okay, so here the advantage is order is irrelevant. We need not know about the order, because even if I write length assigned to n and list assigned to a, the order, exchange the order also, no problem, because since I am mentioning the names of the formal parameters. Okay, so the only disadvantage here is user must know the formal parameter names. Okay, user must know the formal parameter names. And the some of the design issues while designing the subprograms is what parameter passing methods are used or provided, are parameter types checked, whether type checking is provided for parameters, and whether the local variables are static or dynamic, and what is the referencing environment. Okay, and whether they can be nested, that means whether there can be a call of subprogram within a called subprogram. Okay, like p calls q calls t calls something else, like that. So those are nothing but the nested subprograms. Okay, and can the subprograms be overloaded? Like, can we have a subprogram with the same name and different values? Okay, and is there any independent compilation supported for subprograms? All these are the design issues, and we'll be looking at them one after the other. So let us first discuss on the first issue, whether the parameter passing methods are available and whether their local variables are static or dynamic. So one way is the variables can be static and the other way they can be stack dynamic. What do we mean by this stack dynamic is, suppose if the variables of a subprogram are stack dynamic, they will be initiated or they will be binded to the memory when the execution starts, and they will be deleted or like the refreshed from the memory when the execution ends. Okay, so this is how it happens. Like they will be allocated when it starts execution, and once the execution is over, they will be out of the memory. So the advantage is it is recursion will be supported easily, and the memory locations can be shared with the local subprograms. But the disadvantage is every time you execute the subprogram, you are allocating and deallocating. Okay, you are allocating and deallocating, and indirect addressing is used. Since indirect addressing needs calculation of effective address, then it is always little bit time consuming only. And subprograms cannot be history sensitive. When you are always when you are coming out, you are like you are flushing out all the information available in the memory. Once execution ends, everything is out of the memory. When next time when you are going, it is a fresh new start only, so there is no chance of history being available there, right? So that is the reason the subprograms which support stack dynamic local variables, they are called as, they will not provide history sensitivity. Then the static variables or the static local variables are quite opposite to this. Like they are, when the program is started execution, they will be allocated, and unless and until the usage is done, they are not deallocated. And the following are some of the examples of languages using the different methods. Some of them use static and some of them use stack dynamic. As you can see, Fortran 77 and 90 versions are using static. Okay, and C has both variables, but the default one is stack dynamic. Pascal, Modular 2, ADA use only dynamic allocation. Now, here is a question for you. What is the difference between function and procedure? Do you think that there is a difference between a function and a procedure? Since we are discussing about the subprograms, it is required that you should know the difference between a function and a procedure. Yes, the difference is functions return a value whereas a procedure does not, right? Functions receive an input value from us and they process that and they will return back the value, whereas procedures are just processing. Their task is processing the information. Okay, then parameter passing. When you are calling a subprogram, passing parameter values to the subprogram can be done in many ways. There are two methods available: semantic models and implementation models. Semantic models and implementation models. Semantic models are like the data or the parameters can be passed in mode, out mode, and in out mode. In mode, in the sense, you are only sending the data to the subprogram, but you are not expecting any result back. In out mode, you are not giving any input to the subprogram, but you are expecting an output from the subprogram. In out mode, we both provide an input and we'll get back the result from the subprogram. We are also getting the result from the subprogram. Okay. So implementation models, there are different implementation models like pass by value, pass by result, pass by reference, okay, pass by name. So all these we'll be discussing in the next class. Thank you so much.